Okay, ladies and gentlemen, we are on topic 13, student activity sheet 2, exploring rational exponents. And let me tell you, if you guys only knew how many times I have attempted to make this lesson for you. Whew. All right, so real quick, backing up just a step, I want to talk about what exponents are made of, what an exponential term is made of. We have the base with its exponent. Sometimes it's not a number, but sometimes it's a variable. The variable is our base and the little number is our exponent. So let's look at this first problem. They want us to go through these and use what we do to write what is the multiplication law. So with that, we have 4 to the third times 4 squared. So we expanded this out. Remember, exponents means to multiply something by itself however many times it says. So this is 4 to the third. That means 4 times 4 times 4. And times 4 squared, which is 4 times 4. Now, look at this. All of this, including the two sets, are multiplication. So that's really 4 times 4 times 4 times 4 times 4, which is 4 to the fifth. Well, what did we do here, guys? Check it out again. 5 squared times 5 to the fifth. 5 times 5 times 5 times 5 times 5 times 5 times 5 is 5 to the seventh. Here, when I count it up, 10 squared, 3 to the fourth, 10 to the third. I count up those 10s and I have 5. I count up the 3s, I have 4. What is the rule? When we have the same bases, so that would be the 4s, the 5s, the 10s, the 3s, carry the base and add the exponents together. The division law, guys, when I go through here, so I wrote it out the same way, and what I did was put them in a loop, cross them out. Okay, I am left with just a single. If it's single, then you got to put a 1 with it. Okay, and here, where are my 7s bigger? When you cross things out, you realize that they are bigger on the bottom by 3. Okay, remember, we do have to state what is left on top. Okay, if it's single, put a 1 with it, guys. Beyonce is the answer to everything. Down here, next problem. Same idea, even though we have different bases. Okay? The 2s focus on the 2s. The 3s focus on the 3s. Well, when I do this, my 2s are bigger on top by 1. My 3s, they gone. I am just left with a 2 over 1, which equals 2. Down here, again, cross them off. My 2s are bigger on top by 2. My 3s, when I simplify, are bigger on the bottom by 3. And I'm left with 2 squared over 3 to the third. What did I do here? Well, guys, the big idea is what we did was we subtracted. Okay. That said, what did I really do? I asked, where are my exponents bigger? And how much are they bigger by? So, for example, down here, I've got 5 to the fifth over 5 squared. Where are they bigger? They were bigger on top, so my answer goes on top. How much were they bigger by? There's 3 extra up there. My 2s, where are my 2s bigger? Well, there's more of them down here. And how many extra are there? There are 2 extras. Go ahead and turn the page. Okay. Number 3, same idea. We're going to write the power rule. Guys, all the power rule is we are simply distributing. You could see here how it's worked out. When I square something, that means to multiply it by itself. So 4 to the third and then squared means 4 to the third times 4 to the third, which is really 4 to the sixth. All you had to do was multiply. And you could see it on these examples here. I could have just said 3 times 4 gives me 8 to the 12th. Take this 2 out here, distribute it. So I should get 2 to the 6th and 3 to the 4th. On this problem, that is a 4 to the 1. Again, if it's single, then you got to put a 1 with it. So multiply 5 times 3 to give me 3 to the 15th and 1 times 3 to give me 4 to the third. Okay, what is my rule? Keep the base, multiply the exponents. And because they are outside of parentheses, I want you to think distribution. Okay, number 4. Same idea on this problem. We're going to look at 2 ways that we talked about the division rule. Okay, we talked about where are they bigger, how much are they bigger by. What I mentioned but did not actually show was that what we do here is we subtract 3 minus 5 is negative 2. Okay, What I want you to see is how these two problems are the same answers. 1 over 4 squared is the same as 4 to the negative 2, okay? And why is that? Well, really, we don't allow negative exponents in our final answers, okay? The math gods that be say no negatives in your final answer. Therefore, to get rid of our negative exponents, we move negative exponents to the other side of the fraction bar and make them positive. So here, we moved it to the other side of the fraction bar. We put it underneath and made that exponent positive. Here's a couple of examples here. Okay, 5 to the negative 3, put it on the bottom, make it positive. I'm left with a 1 on top. Here, only that 3 has the negative exponent, so the 3 goes to the bottom, makes it positive. Here, this is our proper way. That is how we want to write it. Okay, however, Agile Minds is asking us to rewrite it. So how would I rewrite this? Well, it's positive, so I'm going to rewrite it with a negative. I'm going to do the same thing. Put it on the other side, make it negative. Okay. And question 5. Last rule here is the 0 power rule. The big thing that you guys need to understand is that anything, let me put this up so you can see some of those answers. Anything raised to the 0 power equals the whole number 1, whether it's a variable or a number or an elephant. Not really an elephant, guys, but just to prove my point, I could take this, raise it to the 0 power, and it would equal the whole number 1. Okay. Question 6. They just want us to determine which way we're going to simplify this. This first one, guys, just because they're fractions doesn't mean anything. Okay. Which law am I going to use? This is the power to the power rule. Power to power, which means that I have to multiply. And as a reminder, when we multiply fractions, multiply the top, multiply the bottom. And I end up with 5 to the 3rd. On this rule, this is division, so we would subtract. So we're going to say 3/4 minus 1/2. Guys, think of it as quarters. I just said 3/4 minus 1/2. Think of that as money. So 75 cents minus half. Well, that's 50 cents. 75 minus half gives me a quarter, which is 25 cents there. Okay, here we have same bases being multiplied, so we have to add them. Okay, you got to find your common denominator. And with that, my final answer is 2/3. Down here, a couple ways we could do this. We could distribute that 0, but it doesn't matter because the entire thing is being raised to the 0 power. Anything raised to the 0 power equals the whole number 1. Okay, and on this page, guys, we are simply just going to state the rules. Okay, what do we need to do here? We need to multiply. Here, we add them, subtract them, put them on the other side of the fraction bar. I also show how we get rid of the fraction that's on the denominator. We move it to the numerator. And anything raised to the 0 power equals 1. Okay, your next couple problems are reinforced that you will do with your teachers. Okay. On number 10, the big idea here, guys, is you need to simplify first. Okay, simplify first. So when I look at this, I have same bases inside. Where are my 2's bigger? They are bigger in the numerator by how many? 5. Now I have 5, 2 to the 5th power raised to the 3rd power. Multiply those to get 2 to the 15th. Same thing on this problem. Simplify, we just did this 3/4 minus 1/4 leaves me with 2/4, which is 1/2. 1/2 raised to the 1/2, multiply them, and we get 1/4. Okay, number 11, you're going to do in class with your teachers. Go ahead and cross off number 12. We're not going to do that problem. Number 13 and 14, go with your teachers. Okay, so now my next question here, number 15. Do we think that 3 to the 1/4 times 27 to the 1/5 can be simplified using laws of exponents, and why? Okay, well, a couple things to think about. The first thing I notice, guys, they are not the same bases. So typically we would say no, not as it is. We need the same bases. But can we actually write it differently? Can we write it with same bases? So let's take a look at this. Okay, so 3 to the 1/4 times 27 to the 1/5. 27 to the 1, guys, 27 is the same as saying 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Okay, so it's the same exact problem. Okay, again, because there's 3 of them, that's the same as saying 3 to the 3rd. And we're going to go ahead and do 3 times the 1/5 to get 3/5. And then these are our addition rules. And when we add those two fractions together, we get 17 over 20. Okay. Now the next thing I want to talk about on this, just a little bit of practice here so you guys can see this. 16 and 64, we got two different bases here. Well, let's break them all down. I know the square root of 16 is 4. 4 squared is 16. 4 also is a root of 64. It's 4 times 4 times 4, so it's 4 to the 3rd. Okay, I go ahead and distribute that. 2 times 1/3 is 2/3. 3 times 2/3 is 6/3. Okay, add those together and we get 8/3. Down here, 16 breaks down into 2 to the 4th. 32 breaks down into 2 to the 5th. So I'm going to go ahead and do my properties here. 4 times 1/2 is 4 halves. 5 times 1/2 is 5 halves. We're going to go ahead and subtract those. We get negative 1/2. Negatives go on the bottom. Okay. On this, what are our powers of 3? Well, anything raised to the 0 power equals 1. 3 to the 1st power is 3. 3 squared is 9. To the 3rd is 27. To the 4th is 81. To the 5th is 243. According to this table up here, what is the principal square root of 9? Okay, well, 3 squared is 9. So the square root of 9 is 3. Those are inverse operations, guys. Okay, so now that we know that 9 to the 1/2 power means the same thing as the square root of 9. Okay, some things I want us to think about. Something to get down, guys. What I want you to understand, okay? Anything, I'm just going to use a variable for this. Any number, okay, to any type of root, okay? That exponent, that power, if that power is a fraction, that denominator becomes your root. Okay, so for example, okay, 9 to the 1/2 power is the same as saying the square root of 9. Okay, we'll look at some more examples of this here. So again, for example, the square root of 9 is 3. 9 to the 1/2 power is 3. Also, guys, we don't want to write 3 as a root 2 times. We're going to write it as an exponential fraction. Okay, over here, the cubed root of 27 is 3. 27 to the 1/3 root is 3. So they mean the same thing, guys. Okay. 4th root of 81 is 3. 81 to the 1/4 is 3. 243 to the 5th root is the same as 243 raised to the 1/5. Okay. Same thing, guys. We go through that same exact table with with 2's. And then we're going to go through that same exact table with 5's. Okay, now I'm going to use those numbers that I just got to go through some of these problems here. Okay, I can reduce this fraction to say 2 to the 1/2. 2 to the 1/2 equals 2 to the 1/2. Over here, this is like saying the square root of 2. This is saying the square root of, this is saying the square root of 2. This is saying the square root of 3. Well, guys, the square root of 3 is bigger than the square root of 2. Here, this is the square root. This is the 4th root. That means they're making it even smaller. They're splitting that into 4 even pieces. This is splitting it into 2 even pieces. So with that, this is going to be bigger. That means 1 over 2 squared, and 1 over 2 squared is the same as saying 1/4. Well, the square root of 2, okay, is bigger than 1/4. Down here, I'm going to go ahead and distribute that, and that equals 3 halves, so that is equal. And lastly, I put these into the exponential form here, and 17 out of 12 is bigger than 6 out of 12. Okay? And that is it. Have a good day. Bye.